Section 4.5, we're going to work on proving triangles are congruent using two more theorems, angle side angle and angle angle side. So this just is an extension again of congruent triangles and how can we prove them congruent without proving every corresponding side and every corresponding angle is also congruent. So with this particular idea, the first postulate is angle side angle congruence postulate. And if two angles and the included side of one triangle are congruent to the two angles and the included side of the second triangle, then the two triangles are congruent by angle side angle. So this is our other sandwich theorem. And remember, the side has to be the included side. So it has to be included between the two angles that you are given. So you're given these two angles are congruent and it has to be included side. And so that what we have is angle, side, angle, angle, side, angle. Okay, so that's one of them. And the second one is angle, angle, side. So this one is two angles and a non-included side. So you have angle, angle, side. You have angle, angle, side. But again, it has to be in the right order. So the corresponding angles must be congruent. So if two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. And really, this can really be thought of as an extension of angle side angle, because we actually know that this angle B and angle F are also congruent to each other by the third angles theorem. So we could actually, just as an extension, find that that angle is also congruent. So we actually could use angle, angle, side or angle, side, angle again. So those are our last two congruence theorems and ways to prove triangles are congruent. So let's determine if we can prove these triangles are congruent. And if we can, we're going to say why or why not. So this is asking, is triangle TNS congruent to triangle UHS? Well, angle T and U are corresponding and congruent. And we have angle N and H are corresponding and congruent. And S is corresponding and congruent, even though it's not marked that way, but because of vertical angles. But what we have here is we have angle, angle, angle. That is not one of our congruence theorems or postulates, so no. We need at least one side. We always need at least one side for any of these. So keep that in mind. You're always going to need at least one side. So we cannot use angle, angle, angle. That is not one of our congruence postulates or theorems to use. So let's look at another example. So triangle KLN, is that congruent to MNL? Well, we have this angle is corresponding and congruent. We have this reflexive side. So far we have an angle and we have a side, an angle and a side. And we don't have anything else marked, but always look for vertical angles. We don't have any. Look for parallel lines. Oh, we do have parallel lines. We have parallel lines right here, cut by that transversal. And so we actually have these angles right here are alternate interior angles. They're also congruent. So now we have another angle. So what we have is angle, side, angle. So yes, we can prove they're congruent by angle, side, angle. Let's look at the next example here. Can we prove these triangles are congruent? Well, what we have is we have this side right here is one tick mark plus 3 tick marks, and this side right here is also 1 and 3. So this side is corresponding congruent to this side. We also have that these angles are marked congruent. So we have this angle and this angle are marked congruent. So we have an angle. So in this red triangle right here, what we have is we have this angle right here, this side right here. And I'm going to highlight the other triangle in blue right here. So what we have is we have this side and we have this angle right here. So far we have an angle and a side, but we don't have anything else marked. But if you look at this side right here, it is 2 tick marks plus this segment in the middle right here. And it's overlapping with this other side that's 2 and that same length. So we actually do have another side, YW, in the blue triangle, and we have XZ in the red triangle. So what we have is we have side, angle, side, and in the blue triangle, we also have side, angle, side. So yes, we can prove it with side, angle, side. Now it makes a difference. The order makes a difference. So make sure you are understanding we're kind of going in order. And let's look at this last one. We have an angle in this triangle, and we have an angle in this triangle. We have a side, and we have a side. And we also have this side is reflexive, so we actually have this side is congruent to itself. So what we have here is we have angle, side, side. So what we have here is we have angle, side, side. And in the other triangle, we also have angle, side, side. So it looks all well and good, but angle, angle, side, sorry, I misspoke about that. Angle, side, side, or sorry, I wrote this incorrectly. So we have angle, side, side, or side, side, angle, and that is not one of our congruence postulates that we can use. So this is no. How about these two? Why don't you see if you can figure out and try these two on your own and see if you can determine whether they're congruent. So what we have here is we have this angle and this angle are corresponding and congruent, so we have an angle. We have this side and this side, so we have a side. We also have this angle and this angle with vertical angles, so we have another angle. So what we have here is we have angle, and we have an angle, and then a side. That's the order. So we have angle, angle, side in both triangles. Again, I'll show you it's angle, angle, side. Angle, angle, side. If you're wondering, is that the one we can or can't use? Look at it backwards. If you write it SAA, that's just fine. So this one is yes. The one that we can't use is the one with 2 sides and an angle, when the angle is not included. And if you did the next example correctly, we have a right angle here and a right angle here. So we have an angle. We have another angle here and another angle here. And then we have a reflexive, we have a side, not reflexive, just a side marked. So again, what we have, if we go in order on this triangle, is we have the right angle, then we have the congruent angle and the side. And on the other triangle, it's in the same order. You have the right angle, the congruent angle, and the side. So yes, by angle, angle, side again. Now notice, many people automatically, when they see a right angle, think it's going to be hypotenuse leg, and that is not always the case. Okay, so This is using our ideas in a slightly different way. It says, state the third congruence that is needed to prove the two triangles are congruent using the given postular theorem. So, in this first example, it tells us that angle E and angle R are congruent. It tells us that EF is congruent to RT. So what else would we need to have congruent in order to use angle side angle? Well, what we have is we have an angle and we have a side. So we need another angle in that order. We need angle side and we're going to need that angle. So we will need that angle F will need to be congruent to angle T. So now let's look at another example. We're using those same two triangles just sort of generically. So now, if we use what's given, in this example, we are given that angle D is congruent to angle Q, and we are given that angle F right here is congruent to angle T. And what would we have to have congruent using angle, angle, side? So right now we have angle, angle, and we need that side. Angle, angle, we're going to need this side right here. So we will need that RT is congruent to ET. Or sorry, EF. All right, last one here on this. So this particular example, we're given that DE right here, we're given DE is congruent to QR. So we're given that these two sides are congruent, and we're given again that angle Q is congruent to angle D right there, and we want to prove with side, angle, side. So we're given this side, this angle right here now again, so we're going to need this other side. So we are going to need DF being congruent to QT. So that's what we will need in order to use that particular theorem. All right, so these are the ones that we can use. We can use side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. Those are the 5. And notice you always need at least one side. So keep that in mind. Which ones can't you use? You cannot use angle, 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 or side, side, angle. Those are the ones that we cannot use. And that is the end of lesson 4.5.